Hello, Coach Holmes here, and today we're going to be talking about similar polygons, so similar figures, all right? And what we mean by that is that instead of working with congruent figures, they're actually going to be very similar in shape, but they're going to have different sizes. And of course, those sizes are going to be corresponding to each other by the same ratio for all three sides, or four, depending on rather the quadrilateral and other figures. Okay, but we gotta get get a good understanding of what similar polygons are. Similar polygons are polygons which have the same shape but different size. Just like what we said before, they're going to have the same shape. The shape is going to be very similar. It's going to be basically the same, but it's going to be a different size, though. It's just one good example is we talk about dilations. All right, when we dilate a triangle, making it bigger or smaller, the triangle keeps its shape when you dilate it, but the size will be different. And like we said before, the size is going to be by the same ratio. Now, what's significant about similar polygons? Two things that's always going to be the same. All corresponding angles are congruent. So no matter what, when I make a figure bigger or smaller, the angles are going to be the same. Now, all corresponding sides let me make this a better E, are proportional. Alright, so the sides are going to be proportional based on based on a certain ratio. And we call that a scale factor. Remember, we call that a scale factor because a scale factor tells us how big or how small the figure is going to be. So we're still using the same vocabulary from Unit 4 or Unit 3 based on transformations. But what the difference is that we're given similar figures. So we got to determine if they either are similar figures or they're not. But we just got to know that the sides are going to be proportional to each other. So here's an example. We want to find the scale factor and congruent angles. Okay? So we want to find the scale factor. So remember, I know that each side here, corresponding side, so if I'm doing BE, that's going to correspond with AM. Okay? Now, if I do EN, that's going to correspond with MY. Alright? And I know that they're going to be the same because they're going to have the same scale factor. And then BN here is going to correspond with AY. So the one thing I know for sure is that corresponding sides are going to be proportional, which means they're going to be the same thing. So if I just plug in the values, for example, I replace BE with 30, AM is 18. Well, I also know that EN is 25, MY is 15. And then BN is 20, AY is 12. So what exactly is my scale factor? Well, by looking at it, if I If I divide the 30 by 6, that gives me 5. Divide 18 by 6, that gives me 3. So basically if I simplify 30 over 18, I get 5 over 3. Well, I should be able to do the same thing by simplifying 25 over 15 to get 5 over 3. And if I simplify 20 by 12, that gives me 5 over 3. So my scale factor for this is 5 over 3. Okay? Now, again, what about the angles? Well, remember that the angles are congruent to each other. So that means that angle B here, let me put it in blue. Angle B is congruent to angle A. Angle E is congruent to angle M. And angle N is congruent to angle Y. So one of the things we definitely know for sure is that corresponding sides are proportional to each other, which proportionally the scale factor is 5 over 3. And the congruence, and the angles are congruent, which I just know that these angles are equal to each other. Luckily, we don't have to worry too much about angles, but it's nice to know that the angles are going to be congruent to each other, which, when all angles are congruent to each other, that's what makes it a similar figure for sure. Okay, that's pretty much a guarantee. That's pretty much going to help us out. Now, I also want to be able to find x. Okay, I want to be able to find x. So one of the things I know for sure is that the sides here are proportional to each other. So I can do x over 7. You can do 7 over x, and that's perfectly fine. But for this next part, which by the way doesn't matter which side I use, has to be with the same ratio as x over 7. Okay? So for example, in this case, I'm doing the first figure over the second figure. That's how I'm doing it. Just to give you a perspective. And again, you can do the second figure on top, but that means that for the next problem, the side from the second figure has to be on top. But I'm doing this figure on top. So it doesn't matter which one I choose, but I'm going to do 10 here. 10 over proportional or corresponding to 10 is a length of 5. So I put a 5 here. I want to cross multiply, which means I'm doing 5x equals 7 times 10. 7 times 10 is 70. Divide that by 5. I get x equals 14. So the length of CD here is going to be 14. And that's how I actually go about solving for x. As long as I know which sides are corresponding to each other, I can set it up according to this and be able to solve for x. Just by cross multiplying, and then you just do algebra from there. Now, for this one, this is one thing that's unique when it comes to similar figures. It's a unique factor. We want to be able to find the scale factor, but we also want to find the ratio between the perimeter of these figures and the area of those figures. Because there's something unique that goes on with perimeter and area. So one of the things that goes on here is that if I want to find scale factor, remember, I just got to do the first figure over the second figure. So in this case, 15 over 18. Well, if I find the ratio of it, if I simplify it, I just got to divide both by 3. 5 over 6. and that gives me and that's the ratio or the scale factor. Now if I try to find the perimeter, remember, I have to add all these up. So 15 plus 20 plus 25. Battery's dead. And I bet this one is too. Yeah, well, here we go. 15 plus 20 plus 25. That gives me 60. And I want to add these two up. So for the perimeter, the ratio, remember, I'm going to do the first figure over the second figure. 60 divided by 72. It's 5/6. Okay? So the ratio for the perimeter is the same thing for the scale factor. It's the same thing. Now, would that be the case for area? That's only one way to find out. We got to work it. So I know, and I'm going to do area in red. So that way you distinguish which work I'm doing. 15 times 20 divided by 2. That gives me 150. And then 18 times 24 divided by 2. 216. Remember, first figure over the second figure. If I simplify that and put it in my calculator, that gives me 25/36. Now, they're not the same, but notice how they relate to each other. If I square 5/6, that gives me 25/36. So the area is the ratio. I'm sorry. Let me start over. The ratio of area is the scale factor squared. So if you square the scale factor, you get the ratio of the area. And that's how you go about finding it. That's what we want to be able to do. Okay? If we want to find the area for a similar figure, we just square the scale factor. So as long as we are able to find the scale factor, as well as be able to set up proportionally, similar figures will be easy to work out. We just got to remember that the similar figure is based on the scale factor, which the scale factor is the proportional corresponding lengths of the figures. Thank you and have a good day.